Hi, everybody. I'm going to do K6. This is for IXL, Algebra 1, and we're solving single variable inequalities. And K6 is solve one-step linear inequalities. So apparently they're going to do addition, subtraction, multiplication, and division. So we're going to get started right away. And it looks like fun. So do a little bit of these. Let's see what we got here. We're going to subtract 4 from both sides. So I'm going to go ahead and write the first few out, kind of explain what's going on. It says p plus 4 is less than 9, and we're going to subtract 4 from both sides. We're using the subtraction property of inequality, and this tells us that p, by the way, 4 minus 4 is 0, and p is less than 5. Now, this has an infinite number of solutions, which is different than the equation type that you get. Now, if you were to graph this solution set, here's 0. I'm just going to be lazy and put the 5 and the 10. Not quite proportional there. We have an open circle at 5 because it's not included, and we want all the numbers less than 5. So P is 4 and 3 and 2 and 1 and negatives and so on. Another way that they'll write this in textbooks is like this with an open parenthesis. And the reason that we want to use this on occasion, this open parenthesis, is that if I were to write this in interval notation, it would be negative infinity, which is way out here in this direction if you keep going. And it goes all the way up to 5, but does not include 5. If 5 was included, then I would use the bracket. Anyway, a lot of stuff going on there. Let's go with p is less than 5. And then I'm just going to move right along here. In this one, we're going to divide by 2 on both sides. And I guess I should include this one as well. 2q is greater than or equal to 10. And we're going to divide by 2 on both sides. We're using the division property of inequality. And q is greater than or equal to 5 in this case. And the difference is we're going the other way. We're going with larger numbers. Here's my 0 and my 5 again. There's my 10. And this time we're talking about q. It's always good to label your number line. And we want to include 5 this time. And the way we indicate that is by filling in. And we're going to be larger than 5 or equal to. And if like I said, some textbooks are going to use the bracket. And the reason the bracket is included is because the 5 could be, Q could be 5. It doesn't seem like a big deal because 4.999, what the hell, it's close enough to 5. But you, in mathematics, were being very specific. So my interval notation would be 5 all the way up to infinity, and I'm going to get as close as possible, but I'm never going to quite get there. So there's your interval notation, your graph, and your solution. And this is q is greater than or equal to 5. Probably too much information, but there you have it. Very common mistake in this one is to be tempted to divide by 2. And the reason is because a lot of students will see this C divided by 2, and they're going to want to do something with it. Well, what I need to do is get rid of it, this 2 in the divisor or in the denominator. So what I'm going to do is I'm going to multiply by 2 on both sides. I'm really multiplying by 2 over 1 if you like. 2 divided by 2 is 1. It doesn't just go away. C is greater than or equal to 4 in this case, and I'm just going to put it in. Okay, we're going to subtract 8, and we're going to get v is less than 1. I'm subtracting 8 from both sides of the inequality. I'm going to subtract 7 from both sides of the inequality and get t is less than 2. And we're going to move right along here and see if we can get finished. I'm going to multiply by 4 on both sides and get r is greater than 16. What? What did I do? Oh, it said less than? Sorry, guys. Got to read my, I have to get my glasses checked. All right, so we have n is less than or equal to 5. There we go. Slowed myself down a bit. It's always good to make a mistake on occasion. Now, here is a problem. I have a divided by -1, and I want to make sure that I address there's quite a few problems with this. First of all, I need to multiply by -1 on both sides of my inequality. So I'm going to multiply by -1 on both sides. And the -1 cancels with the -1 and divides and gives me 1. I shouldn't say cancels, it's literally 1. Now, the problem is that because I'm multiplying by a negative, it changes the sign of both sides of my inequality and changes the sense of my inequality. So I have to change the sign, the symbol for the inequality. And this is a rule when you are multiplying or dividing by a negative on both sides of an inequality. And all of that has to be true. And here's the reason. I'm just going to give you the quick reason for why this is true. Everyone can probably agree that 5 is greater than -3. But look what happens when I multiply by a -1 on both sides. If I multiply 5 by -1, I get -5. And when I multiply -3 by -1, I get +3. All I did was more or less what I did up here. I multiplied by -1 on both sides. And what happens is I've reversed the sense of the signs on the two sides of the inequality, and I have to reverse it. It's a bit like the rule where when you are dividing by a fraction, you have to multiply by the reciprocal. Um, anyway, one other thing that I want to mention is that if I read this, it says a is greater than -2. If I read this from right to left. If I read it from left to right, it says -2 is less than a. Both ways are correct. But what happens is a lot of students get this backwards. When they write the a on this side, they forget that a has to be greater than -2. So there's a lot of things happening here. You can write either one of these. This one is probably the safer one. And I get -2 is less than a. Notice that I changed the sense of the inequality. Okay, there's a lot of stuff going on there. So I'm going to let it go for now. J is less than or equal to 8 because I'm multiplying by 2 on both sides of my inequality. And now I'm going to divide by 4, and I'm going to get 2 is less than h. See if I can manage to keep my inequalities the right direction this time. And this one, I'm going to add 7 to both sides, and that's d is less than 10. In this one, I'm going to divide by -1, and I'm going to do one more where I change the sign. Is greater than or equal to 2. And I'm going to divide by -1 on both sides. By the way, you might have noticed that I could have multiplied by -1 on both sides. If you ever get one of these wrong, you'll find that in general, if there's a -1 involved, um, the IXL will generally multiply by -1 every time. Now, hopefully you noticed that I didn't change my sign, and that is a big red flag. Make sure that if you multiply or divide by -1 or any negative on both sides of an inequality, you have to change the sign. And I really want to point this out. It's very important that you try to remember that when you change the sign, you have to change the sign. And r has to be less than or equal to -2. And I'm just going to go ahead and put it in. I think I've probably over covered it, so it's all good. I'm going to divide by -5, and I'm going to change the sign. N has to be less than -2. I'm going to subtract 1 or add a -1, same thing. Q is greater than -9. And I'm going to add 79 to both sides and get 55 is greater than or equal to V. I could turn it around, but it's probably better to just leave it the way it is. I'm going to divide by 20 on both sides and get R is less than 4. I'm going to multiply by -10 on both sides. And what else? I am going to change that sign because I multiplied by a negative. That's going to be +20. Now, a good idea is you could go ahead and check your answer. And here's what I'm going to do. I'm going to choose a number that's less than 20, and 0 is less than 20. 0 is a good test number because it's easy to deal with mathematically. So I have 0 should be a solution to this inequality because it's less than 20. And I'm writing, is this, sorry, no, what I'm gonna do is I'm gonna put it in the original inequality here. So look at my original inequality, and it says C over -10 is greater than -2. And if I put a 0 in for C, I'm substituting inside parentheses, is this true? 0 divided by -10 is 0, and is that greater than -2? And we can see that it's true. I like using 0 for a test point in a lot of my videos. I'm going to show you that that's the case, but I didn't have to use 0. I could have used any number less than 20. For example, I could have chosen 10, and I could have chosen any negative as well. If I chose -10, we would have gotten -10 over -10 is 1 is greater than -2, and it's also true. Anyway, just a way to check them, and you can check your solutions that way. I'm going to move right along now. We get F is less than, and I'm going to add 79 to both sides and get 90. And we are done. What? 93. Oh my God. I could have sworn I saw 11 there. I don't know what's wrong with me today. Sorry, guys. Well, looks like I got 2 wrong. We'll see how long it takes me now. Add 53 to both sides. Let's see if I can actually do my work today. I'm going to do it in my head. I have to not. Okay, so it's going to be a positive because the positives are going to win. I'm going to add 53 and 36 and get, looks like 17. But I'm going to check my work this time. Yeah, this time it's right. Man, easy to make mistakes, isn't it? I'm going to multiply by 2 on both sides and get S is less than 56. It's a good idea to do your arithmetic because occasionally you're going to make mistakes. And there's nothing wrong with that. It's part of doing your work and practice your arithmetic as you go. I'm going to subtract 31 or add a -31. I'm going to get A is greater than or equal to -5. I'm going to get Z is greater than or equal to 100. A lot of students are going to be tempted to grab their calculator. And the problem with grabbing your calculator is that when you do that, you stop thinking. I guarantee, try it. The minute the calculator enters your hand, I promise your brain turns off and you just start pushing the buttons. It's better to engage yourself. You're going to divide by 15 on both sides, and W is less than 4. Knowing your multiplication tables and and your additions and subtractions and being able to work with conjugates is really important. I'm going to add 457 to both sides. I'm going to leave the m where it is. Oh, sorry, I'm not going to add 457. I'm going to subtract 492. Let's go ahead and write this out just so that I have them lined up. Now, if I wanted to challenge, I would go ahead and just do it in my head, but I'm going to go ahead and subtract the 492. Make sure I'm actually using the right number here. And m is going to be greater than or equal to, I'm reading it from right to left, and I'm going to get negative, looks like 949. So negative 949 is less than or equal to m. And I'm going to double check my work. 9, 4, carry the 1, yep. Don't want to make a mistake in the challenge zone, because that's when you start having errors. Now I'm going to show you how I'm going to get my answer. I could do it in my head. I'm going to add 64 to both sides. And the difference between 64 and 51 is 7. So I'm going to end up with negative 593, I believe. But I'm going to go ahead and show you where that comes from. So negative 651 is less than or equal to n minus 64. I'm going to add the 64 to both sides. Now, one good thing is that my larger number is on the top, even though larger absolute value. When I add 64, I'm really taking the difference of these two values, and it's going to be negatives are going to win. Now, it just so happens that 64 and 51 are 7 apart. Now, think about how I'm using that 7 to help me. If this was 51 that I was adding, then it would just be negative 600, wouldn't it? But I'm adding more. So it's going to be negative 593. Think about how I used the 7 in the conjugate to do that. Now you could borrow from the 6 and make it a 5, and borrow from the 15 and make it a 14, and put the 10 with the 1 and make it 11. 4 from 11 is not 3. How did I make a mistake? Okay, well, there goes that idea. 4 from 11 is 7, and 6 from 14 is 8, and I get negative 587. How could I make a mistake like that? It's not right. There's a problem. What did I do wrong? All right, 651 minus 64. They do have a difference of 7, don't they? Yes. 4 from 11 is 7, and 6 from 4 is 8, and 5, negative 587. I'm confused. Oh, 13. Oh my God. My brain is not working today. I apologize, folks. 51 and 64 have a difference of 13. The difference that I should have used is 13. Made a stupid error. Anyway, that's why you practice. Negative 587 is less than or equal to n. How embarrassing. Glad I've caught it anyway, but it is easy to make a mistake, especially when I was overthinking it, doing a double reverse. All right, I'm going to subtract 409, and I am going to do it in my head. J is greater than or equal to. I'm going to subtract 409, which is really adding it, so it's going to be 785. It's going to be negative 785. And I'm going to trust myself to do these correctly. I'm going to multiply by 6 on both sides. I want to mention something. Q over 6 is greater than or equal to -1. And I'm going to multiply by 6 on both sides. And a lot of students are going to say, well, I'm multiplying by a negative, so I must have to change the sign. And the reason I don't change the sign is that I'm multiplying by a +6 on both sides. That means that the sign hasn't changed. I haven't changed the sense of the inequality. And it is a very common mistake to be tempted to change the sign. So be careful of that. Q is greater than or equal to -6. And we're almost done. In this one, we're going to subtract 4.96, and we're going to get P is less than or equal to, notice I'm subtracting 9, it looks like -9, because the negatives are winning on this one. I put the 96 and the 4 together. They are conjugates for real, and it does work. And we're almost there. I'm going to add 5.37 to both sides, and I'm going to get Z is greater than 7.16. Check my work. Looks good. Yeah. I'm going to subtract 2 from both sides and get V is greater than 5.75. And divide by 2.26. Looks like it's going to go in there 3 times. I'm going to double check it in just a minute. But J is less than 3. 2.26 times 3 is 6.78. You can check it. And one more. And we're going to add 19 to both sides. Now this one is going to give me trouble because there is a negative decimal here, and I have 19. Now a lot of people, I'm going to go ahead and use the conjugate. I'm going to tell you what I'm going to do. Basically, what I'm going to do is I'm going to take 4 away from 19 in my head, and that would be 15. The problem is that I'm not really taking 4 away. I'm taking 3.77, and the conjugate is 23. So it's 15.23. Now I'm going to show you what you could do. H minus 19 is greater than -3.77. Now, of course, you could just grab your calculator, turn your brain off, and do it that way. But I prefer to have the challenge. So I have 19, and I'm going to add that together. And I'm not going to change my sign. I'm not multiplying or dividing by a negative. And I am going to have greater than. Now, I'm looking at the difference between these two because I have a negative and a positive number. So I'm going to do this subtraction on the side over here, because to subtract these two, you have to put the larger one on the top, and we're going to have to do some borrows, aren't we? And 19, we borrow from the 1, and it gives me 10 tenths. But I have to borrow from the tenths and make it 9 of them, and because there were 10 of them. And now I have 10 of these, which is 10 100ths. So 7 from 10 is 3, 7 from 9 is 2, and 3 from 8 is 5. And I get the 15.23. Now, a lot of people think it's magic. It's just a thing called conjugates. What I'm doing is I'm thinking of the difference that I need to round up that 77 cents to a full dollar and putting it with it. For those of you who have never seen this done before, cashiers who count up change are literally doing something like this, and they get very good at it very quickly. Chances are you're never going to have to do that, because what McDonald's and Burger King and all of the big chains found was that teaching making change is too difficult. So what they started doing is, instead of having the cashiers or the people who are working on the counter put in give change and actually work with money and work with numbers. They just push the little button with the fries or the burger on it, which is a really sad commentary on our mental abilities. Anyway, I hope you'll practice so that someday, if you're interested in actually making change by hand, you'll be able to do it. 15.23 is less than h, or h is greater than 15.23. And hope you all have a better time of it than I did. Hopefully you won't make a silly error like I made with my difference of 7. Can't believe 51. Well, there we go. That gets you to 100, and I hope you have a nice day. See you back.